Hello. In the previous modules, we have talked about the frequency distributions for the discrete variable, for the continuous variable, and qualitative variables. All those frequency distributions were constructed by observing one variable at a time. Whereas our data is usually not very simple. It contains more than one variable at a time. Therefore, we definitely need to move forward and look at that if there is more than one variable in our data, how do we look at them? Right now in this module, we will be talking about the use of qualitative variables, that how we construct the frequency distribution for two or more than two qualitative variables. But in this specific module, our major focus is going to be only on two qualitative variables. Let's take the data. That was vaccination data, and we already discussed it in the previous modules, where we do have two qualitative variables. One is sex and other one is status. So if we look at the whole data, definitely it may not be very easy to summarize these two variables altogether, which we observed earlier, that we have a variable sex, we have a variable status, and these are their frequency distributions. In these frequency distribution, though as univariate frequency distribution, we are having 6 males, 4 females, and the status talks about 4 having 0 and 6 having 1, whereas in total we have 10 respondents. These two frequency distributions are univariate frequency distribution because of the reason they only talk about one variable at a time. But to step further, if we want to look at two variables at a time, and especially two qualitative variables at a time, look at the grid of rows and column that's called cross tables. Cross table has one variable on the row side, that's sex, and other variable on the column side, that's status. Whereas each row will talk about each category that's available in our categorical variable. Like in the sex, we have two categories, male and female. In status, we have two categories, 0 and 1. The last column and the last row are the column totals, which are also called marginal totals. Whereas this specific column, this specific cell is called grand total. Now, we already know that in our data, we have 6 males and 4 females. On the other hand, we have 4 that has status 0 and 6 are those who have status 1. Let's look at the data to fill in these joint totals. And these totals can also be called counts. Over here, for the first cell, if we look at the very first set of observations here, there is a male whose status is 1. So male whose status is 1, we'll put the telemark here. Female with status 1 is the second one. It goes there. Male with status 0 goes there. Female with status 1 goes here. Then it's male with status 0 goes there. Female with status 1 goes here. Male with status 0, male with status 1, female with status 0, and a male with status 1. So if we look at this data, we can see that there are 3 individuals who are male and those have the status 0. In the same way, there are 3 males who are having the status 1 and only a single female with status 0 and 3 females with status 1. And if we add these values up, either on the row side or the column side, these totals should be equals to 6, 4, and 4 and 6. And they all the marginal total, all the joint totals, they all should add up to our grand total. Let's move further. If we are given this frequency table, and we are already familiar with some rows, the value at some joint totals at certain rows, grid of rows and columns, we can find out some missing observations. Like this should be 6 minus 3. That is this total minus 3 is this total, which is equals to 3. And the same way, you can calculate the value in this cell either way, by counting it from the column side or by counting it from the row side. So it could possibly be 4 minus 1 equals 3, or we can also do 6 minus 3, 6 minus 3, and that should also be equals to 3. Moving further, let's give a code. Since we already know that status is a qualitative variable, and in our previous modules, we have talked about that a qualitative variable, the categories of a qualitative variable can carry specific numeric codes. By the way, having these numeric codes does not necessarily mean that status is a quantitative variable now. These are just the codes. These do not make these variables as a numeric variable. They still will be qualitative variable. So over here, if we say 0 represents not having a disease status and 1 represents having a disease, then in our data, we can look and interpret this table in different dimensions. It all depends upon what goes into our denominator of this fraction. Like in the first one, if we divide 3 by 10, we actually mean we are looking at the proportion of individuals who are male and do not have a disease. So in total, there are 3 males who do not have any disease in our data. If we take the proportion with respect to the grand total, which is 10 here, and multiply it by 100, the answer is going to be 30%, which shows that in our whole data, there are 30% males who do not have a disease. Similarly, for females, if we divide 1 by 10 and multiply it by 100, it gotta be 10%, which means there are 10% females who do not have disease in our data. Moreover, we can look at this table in its marginal totals. Like if in the third one, we will divide 3 by 6. What we actually mean is that among the males, among the male group, there are 50% of the male do not have a disease, whereas the 50% of males do have a disease. And the same way it goes for the fourth one. When we divide 1 by 4, it means there are 25% females who do not have a disease, and we can also say that among the females, there are 75% females who do have the disease. So there are multiple different ways to interpret this cross table. So cross tables are generally discussed according to their order. In general, we say that a cross table is of order R cross C, where R represents number of rows and C represents number of columns. R is the number of categories of a qualitative variable on the row side, and C is the number of categories of a qualitative variable on the column side. Right now, we talked about only 2 qualitative variables, but the order can also be changed if we add a third variable on the row side or on a column side, and it can further be extended. The table right now we discuss is called a 2 cross 2 cross table. where we had 2 rows and 2 columns, which represents that for the variable on the columns on the row side, we have 2 categories, and for a variable on the column side, we have 2 categories as well. Cross tables are widely used to measure and discuss the amount of association between 2 or more than 2 qualitative variables. This whole procedure is recognized in many softwares by the procedure of cross tabulations or cross tabs. Cross tables are also known as contingency table. And when we perform the whole analysis using cross tables or contingency table, we call it contingency table analysis. Thank you.